So here I am in the basement of the Earth Sciences building with a planetary scientist, James Bryson, at the University of Oxford, who's been telling me about the quantum diamond. James, I've already screwed it up. What is the name? It's a
It's a quantum diamond microscope.
quantum diamond microscope, which is going to be doing fascinating, or is doing fascinating research. James has just received a European Research Council grant. It's a 5-year grant to actually measure the paleomagnetics of meteorites. That's bits of asteroid or space material which has fallen to Earth. Some of them could be as old as the solar system itself. And what are you looking for, James?
So we're taking these meteorites and we're taking the individual crystals that make them up and the individual objects that build these meteorites and pulling them all apart and measuring them piece by piece so we can build up a much more complete understanding of how the magnetism in the early solar system was behaving. And then we're going to tie all that together to try and say what role were magnetic fields playing during the entire planet building process to understand, could magnetic fields have been key to planet formation?
And one key aspect of this instrument being in this little box of an area is that you are shielded, or you are shielding the instrument from Earth's inherent magnetic field, correct?
That's right. As soon as you walk inside this room, the magnetic field intensity drops by a factor of 100 to 1,000. So it's much weaker where my hand is now to out here. And that's because we don't want Earth's magnetic field interfering with our measurements of very weak magnetic samples.
And so by measuring the very weak magnetic samples, I think it's underappreciated in the people who follow planetary science, the general public, how much paleomagnetism or the magnetic field from the protoplanetary disks that helped form our solar system, the beginning of our solar system. We don't really. It's an open question as to whether paleomagnetism, this paleomagnetic field, from the protoplanetary disk magnetic field, rather, how much of an impact it had in orchestrating the architecture of our planetary system.
Yeah, it's been very difficult for us to measure meteorites over the sort of 70 years we've been doing quantitative measurements of them. And only in the last 10 years have we actually been able to say that a magnetic field that's been measured in a meteorite definitely corresponds to the field created by the protoplanetary disk. So it's only in the last decade that we've been in a position that we could start understanding this field in more detail. So its role that it played alongside a bunch of other phenomena in the early solar system, its specific role, we've just not been able to quantify until the last decade or so. And the grant that I've got is really going to build on that and start saying, let's measure lots more meteorites, look at it in more detail and build up as complete a picture as possible so we can have a better handle on exactly the role that magnetic fields did play.
And you're going to be measuring a few dozen meteorites with this machine.
We're going to have about a dozen meteorites and break them up into each of them into 20, 30 subsamples and measure all those subsamples and all those meteorites. So we'll be measuring hundreds of subsamples in total.
So in your own planetary scientist role, when you look at our solar system, I mean, the architecture is quite unique.
Mm-hmm.
We are in a coplanar system pretty much, which the orbits are fairly, well organized. What role could have magnetism played in the early solar system to ensure that our solar system did not end up being totally chaotic?
So in the very early solar system, as soon as the sun ignited, we had lots of dust particles throughout the solar system. And those all have to come together to form a planet. And it's that motion that magnetic fields can influence. So it can control the dynamics of how everything's behaving. So it's sort of more foundational, where it says magnetic fields could help move everything together to look at the transport of mass and angular momentum throughout our solar system and help that material collapse to form the first planetary bodies. And that's what we want to know. Was that field strong enough and stable enough to play that role?
And you've also been looking at ALMA the sub-millimeter millimeter telescope operated by the European Space European Southern Observatory, and also the U.S. has a part in it. You've also been studying images of protoplanetary disk and extrasolar systems, and what does it look like when you look at those? Do they look like they've been affected by magnetism, or is it, you can't say, but
it could be. So we're seeing all these rings and substructures and richness in protoplanetary disks that we didn't know was there. And one thing that could potentially play a role in creating those is magnetic fields inside protoplanetary disks. And those rings and substructures, not only could they be created by magnetic fields, they could also impact the structure and intensity of magnetic fields too. So we're trying to say, if we measure a certain magnetic field strength and morphology in our solar system, is that consistent with a ring or a pressure maxima or anything like that, to try and help map what we're seeing in ALMA onto our own solar system as well.
But we're very early days in this research. As you told me in the interview just now, we only detected the first paleomagnetism in a meteorite in 2014.
That directly relates to the protoplanetary disk's magnetic field. Yeah, it was
That's right.
in
Yeah.
2014.
In 2014, 10 years after, you finished a year of your work.
Yep.
On a 5-year grant.
Yep.
And you hope at the end of the 5 years, so we're 2024 now, by the end of this decade, you will have a pretty good idea.
We hope to have a much more complete idea. I mean, I think, it's a career's aspiration to have a complete idea, but I think we'll have, hopefully, a more complete idea of how the protoplanetary disk's magnetic field varied in time and in space, and what role that could have played in planet building.
And we know that, here on Earth, our magnetic field has, arguably played a role in our existence here, and continues to play a role in our day-to-day society. But we don't know about how magnetism affected the very beginnings of our solar system, and that's one of the key questions in planetary science, not just Earth science.
Yeah, what role could magnetic fields have played during planet building is something that we've not thought about that much, but could play a role along with a bunch of other phenomena.
So good luck with your project. We look forward to hearing more in the months and years ahead. And thanks so much for having me, James.
Thank you.